Hello, Windows Analysis. We explore the Windows universe, performance, hidden settings, history, hacks, and updates. If you like understanding your system, stay tuned. Today, we're going to be diving deep, and I mean really deep, into the security architecture of Windows 11. See, this isn't just about a few new features or a fresh coat of paint. Microsoft went back to the drawing board and engineered this thing from the ground up to be a true digital fortress. So let's see how it actually holds up in a world that's getting more hostile by the day. And to get a sense of what we're really up against, just look at this number, 800. That's how many password attacks Microsoft blocks every single second. Think about that. It's a constant, never-ending bombardment, and it makes one thing terrifyingly clear. The old ways of doing security just aren't going to cut it anymore. So, that brings us to the big question, right? What has Microsoft actually done to change the game? Well, the answer isn't some single magic bullet or one fancy new tool. It's a strategy. It's about building layers of defense, and today, we're going to peel back those layers one by one. You know, every great fortress needs a solid, unshakable foundation. For Windows 11, that foundation isn't just some lines of code. Nope, it's built right into the physical hardware of your machine. This is where real security has to start. And the absolute cornerstone of this hardware foundation is the Trusted Platform Module, or TPM 2.0. This little chip is the main reason why it's a mandatory requirement for Windows 11. It's what we call the hardware root of trust, and it basically guarantees that the entire system is built on something that's verifiably secure from the moment you press the power button. To put it simply, just think of it as a physical safe that's been shrunk down and put inside your computer. It's a vault. It's where the system's most secret keys, the ones that handle encryption and identity, are stored, completely locked away from the main operating system and any potential attackers. So you're probably wondering if your PC has one of these. Well, it's actually super easy to check. You can just hit the Windows key and R to bring up the run box, then type tpm.msc and press enter. A little window will pop up and tell you everything you need to know, most importantly that it's active and that it's the required version 2.0. All right, so our hardware foundation is set. It's solid. What's next? Well, now we have to build the walls of our fortress. But these aren't just any walls. We're talking about these incredibly strong virtual walls designed to protect the very heart of the system, the kernel. The whole idea is that even if an attacker gets past your main defenses, the core of the OS remains totally isolated and untouched. This really represents a massive shift in security thinking. See, in the old days, all the critical system processes ran together in the same space, what we called ring zero. A single breach there, and it was game over. The whole system was compromised. But now, with something called virtualization-based security, or VBS, Windows creates a new, even deeper level. You can think of it like a ring -1. It's like a secret bunker deep underground. All the most critical security functions get moved into this bunker, completely cut off from the rest of the OS. And who guards this virtual bunker? Well, that job belongs to a feature called memory integrity. It's also known as HVCI, but its job is actually pretty simple to understand. It enforces one crucial rule. System memory cannot be both writable and executable at the same time. You can write to it, or you can execute code from it, but you can never ever do both. This one simple rule slams the door shut on a huge category of common attacks that try to inject malicious code where it doesn't belong. Okay, so we've got our foundation, we've got our walls, we've got our fortified core. Now we need a really smart guard at the main gate, someone who can intelligently decide what is and isn't allowed to come inside. And that guard is Smart App Control. This feature completely flips traditional security on its head. Instead of having a list of bad things to block, it starts from a position of zero trust. By default, it trusts nothing. It uses Microsoft's massive cloud AI, which analyzes trillions of signals every day to predict whether an application is safe before it even runs. It's pretty cool. It starts in an evaluation mode to learn your habits, and then it kicks into enforcement mode, blocking anything that isn't trusted. Now, it's really important to draw a quick distinction here. Smart App Control is designed for us, the home users. It's meant to be automatic, easy, and cloud-powered. You shouldn't confuse it with its big brother for corporations, which is called Windows Defender Application Control, or WDAC. That's the heavy-duty version that lets IT admins create super strict, granular rules for what can run in their environment. So far, we've been talking a lot about protecting the machine, right? The system. But what about the biggest security variable of all? The person sitting in the chair. Us. This next layer of the fortress is all about protecting the human element.
actively trying to stop us from making those simple mistakes that can lead to disaster, like falling for a phishing scam.
And this is a really fantastic line of defense. The built-in phishing protection in Windows 11 basically acts like a security coach that's always watching your back. It'll warn you if you're about to type your Microsoft password into a sketchy website. It'll even call you out on that bad habit we all have, reusing passwords, by alerting you if you use your main password on other services. It's wild. It will even catch you if you do something like type your password into an unsecured file, like in Notepad.
You know, all these new ways to protect our passwords are great, but they all point toward one almost inevitable conclusion. What if the real end game isn't about building better passwords, but about getting rid of them for good?
And this is where we get a glimpse of the future. Say hello to Passkeys. This is the next evolution of how we log in. See, instead of relying on something you know, like a password that can be stolen or phished, a passkey relies on something you have, like your phone or your computer, combined with something you are, like your fingerprint or your face. The actual cryptographic key never leaves your device. It's locked away in that TPM we talked about earlier. Because nothing is ever typed or sent over the network, it's basically immune to phishing. It's a game changer.
So, we've been on quite a journey building this fortress from the ground up. Let's just take a second to put it all together and see the big picture. The key takeaway here is that security in Windows 11 isn't just a feature, it's an entire system. It starts deep down at the silicon level with that hardware root of trust from the TPM. On top of that, it builds that bomb-proof isolated kernel with VBS and HVCI. Then it posts an AI-powered guard at the gate with smart app control. It even actively defends us, the users, with phishing protection. And finally, it points us toward a future without passwords thanks to passkeys. Every single layer reinforces the others. It is the definition of defense in depth.
And all of this leaves us with one final exciting thought to chew on. With security this deeply integrated, from the chip all the way to the cloud, it really isn't a question of if passwords will disappear, but when. So could this be it? Could this be the generation of operating systems that finally kills the password for good? And that's it for today's analysis. If you liked it, subscribe, leave a like, and a comment. Enjoy tinkering, and see you in the next Windows analysis video.